Go.
Good evening, everybody. Welcome to Near Protocol Philippines. I'm Andy, and I have with me my partner, Forward Jam Tapanta. He's from over there in Manila. So tonight we will be delving into Near's white paper. We're going to have a basic overview of how Near Protocol works, and we're going to be discussing some of the points that we are going to read in this white paper, so that at least we get a better understanding of how Near functions as a whole, and how it functions as a blockchain as well. So without further ado, I'm going to share my screen. We're going to see the white paper, section 5 of the white paper. All right. Can you see my screen?
Yep.
All right. So this is section 5, how Near works. And maybe we're going to be reading first the first 2 paragraphs of this section. So maybe I can ask Orvert, you can read that for us, the first 2 paragraphs.
Okay, so it's a little bit blurry. Maybe it's still moving. But right now I can, I think, okay. This is perfect now. All right, it says, shall we read down?
Yes.
Okay,
Go.
It says, Near provides a community-oriented cloud infrastructure for deploying and running decentralized applications. It combines the features of a decentralized database with others of a serverless compute platform. The token, which allows this platform to run, also enables applications built on top of it to interact with each other in new ways. Together, these features allow developers to create censorship-resistant backends for applications that deal with high-stakes data like money, identity, and assets, and open-state components which interact seamlessly with each other. These application backends and components are called smart contracts, though we will often refer to these all simply as applications here.
All right. Thank you for reading. I think we're going to have to magnify the screen a bit so that we can get a better view. So is it better on your end?
Right. Yeah. Better.
Okay. So I guess we're going to break down the first 2 paragraphs of this section. It mentions here that Near is a community-operated cloud infrastructure. So when we say community-operated, there's no central governance, you can say.
Yeah.
Whether as part of what blockchain, the essence of a blockchain is it being decentralized. So Near also has that essential part of it. The essence of the Near protocol is it being decentralized. I guess we can agree on that. So do you want to add anything already?
Yeah, it actually even deconstruct the word smart contracts, because we often stumble upon this phrase smart contracts, but I think the first paragraph elaborates what smart contracts in its simplest form and essence. It's pretty much like really deconstructing the whole engine of it. That these actually work with one another in different networks, same network, but they just have seamless process, if you will.
Yeah, I like how you pointed that out. Usually we see smart contracts a lot in the blog on social media. They mention these things, and people might be wondering what are these smart contracts. It's nice to know that they refer to it simply as applications. People will get a better sense of what it is. Right. So smart contracts. That's what Near is. Near's infrastructure is built for deploying those applications, decentralized applications or smart contracts. I guess that clears it up a bit for us. the term smart contracts and Near's function generally. So I guess we'll move to our next two paragraphs. I'll be reading this for us. So can you see there?
Yeah.
Okay. So it says here the infrastructure which makes up this cloud is created from a potentially infinite number of nodes run by individuals and organizations around the world who offer portions of their CPU and hard drive space, whether on their laptops or likely professionally deployed servers. Developers write smart contracts and deploy them to this cloud as if they were deploying to a single server, which is a process that feels very similar to how applications are deployed to existing centralized clouds. Once the developer has deployed an application called a smart contract and marked it unchangeable or immutable, the application will now run for as long as at least a handful of members of the near community continue to exist. When end users interact with that deployed application, they will generally do so through a familiar web or mobile interface, just like any one of a million apps today. Okay,
Mhm.
so basically, what we've just read is parang yung structure, infrastructure near. It's very similar to a lot of blockchain. No? They are run by individuals who operate something that we call nodes. These nodes could be uh, personal computers or laptops, and they function. And what they do is like based off of what I understood, where they offer a portion of their computing space, their CPU space.
Yeah.
Yeah, understanding it right. For to verify transactions or validate.
Mm.
Yeah, so that's what makes it decentralized because there's not one, there's no just one, I guess, one central individual or company that's controlling these transactions. It's rather a number of individuals potentially spread over, the world, I guess.
Yeah. Infinite number of nodes. I wonder how, at least how many. Do you happen to know maybe the least required number of nodes for it to become a blockchain network?
Or
Maybe
decentralized. Yeah,
1,000? I don't know.
I'm not really sure as well, but I guess for you to call it, to be able to call it decentralized, it has to require like more than just a handful to go there.
Mm.
And
Okay.
so, yeah, and these, the developers building on blockchain, they write applications, they write smart
Hmm.
contracts, and then they deploy this to this network. So these nodes will all get, from what understanding, all these nodes will get that smart contract, which will
Hmm.
then be able to process whatever data that or do its function, whatever uh, the function of the smart contract is for, over all the nodes, if I'm correct.
Yeah.
Oh, so it's also interesting here. It says that once the developer has maybe deployed the smart contract, it makes it changeable, immutable.
Hmm.
Maybe that's what makes it so secure.
Okay.
Do you have any additional thoughts, Corbett?
Um. So, so I think the if you were to become a node, you offer a portion of your CPU for computing power, um, either on a laptop or more likely professionally deployed servers, such as, I don't know, maybe there are professional node operators, but essentially laptops. I remember Alex Skidanov interviewed 2000 circa 2016, and it says there that it's mobile friendly, which means he mentioned a phrase that Near could run um, on low-end laptops or high-end mobile phones. Even a mobile phone could become a node, but I'm not sure if that's already a reality right now. Maybe that's something that we can ask some
Oh,
blockchain experts. Yeah. So I think that they have pre-planned it so as to make the network even work on um, mobile phones. I'm not sure whether when he mentioned mobile phones, that's regarding the mobile interface,
yeah, I guess so.
but I'm not sure. Maybe it's unlikely that a mobile phone could become a node because it can only go so much. Like the Note 10 that I have has 12 GB, for example, its RAM, and the ThinkPad that I have has 8 GB RAM. So I mean, I'm not a techie guy, but if if a if this kind of a laptop, 8 GB RAM, maybe this can offer a portion of its CPU to become a node. Maybe a high-end mobile phone, such as something that has 12 GB RAM, could also. I'm not pretty sure. Maybe that's a topic to be discussed.
Yeah, maybe next next session.
Mm,
Anyway, yeah, this infrastructure is essentially, as we mentioned earlier, decentralized. There's no one governing body that controls it. It's all spread out across these nodes. And I guess the next paragraph will explain the difference between a centralized cloud and a decentralized cloud and offer a good comparison as to how they function and the benefits of having decentralized over centralized cloud. So
yeah.
we can go to our next paragraph.
Just one paragraph.
Yeah, just one paragraph.
Okay, it says in a, in a centralized cloud hosted by Amazon or Google, developers pay for their applications each month based on how much usage they required. For example, based on the number of requests generated by users visiting their web pages. The Near platform similarly requires that either users or developers provide compensation for their usage to the community operators of this infrastructure. Like today's cloud infrastructure, Near prices usage based on easy to understand metrics that aren't heavily influenced by factors like system congestion. Such factors may make it very complicated for developers on alternative blockchain based systems today. Hmm.
All right. So that's how Near differs. Near's platform differs from centralized cloud of maybe let's say Amazon or Google.
Hmm.
Developers who would typically want to deploy yung mga applications nila on the platform or on Google, let's say, they would have to pay some sort of fee. It says, if their app requires a lot of data usage, then they could be paying higher fees. Also,
Mm-hmm.
maybe if their application is maybe let's say a social media application where a number of lots of users are using the application. So lots of users means more data usage, more requests and visiting their web pages or their sites. So that entails more fees.
Mm. Okay.
So uh, maybe you can explain over how Near differs from those centralized clouds of big tech companies.
Well, I guess that so it's now shared of a load, shared load, right? Instead of paying just one big humongous chunk of provider that is server service server um, yeah, server products. This time, the nodes are getting paid
Yeah,
because they have to be compensated because they use electricity, they use their computing power, the wear and tear of the device will also be put into consideration. And so, to some degree, since they contributed to the the transactions and the process, the smooth flow of the system, they have to be in some way, in some shape or form, be compensated.
yeah. But this compensation, I guess, isn't, yeah, as mentioned, it's not heavily influenced by how many users are using their system or the network. It's it's based on easy to understand metrics. So I guess they've got some, uh, they've calculate based on other factors, which makes it easier or lighter. You don't have to pay high fees if
Mm.
developers want to use their platform. So I guess more on this uh, in a future discussion. But yeah, compared to centralized clouds, Near's decentralized platform is a lot way cheaper. That's what I think they're trying to say here in this paragraph.
I can only imagine because look, like Amazon or Google, these are publicly traded companies, correct? These are on stocks exchanges, and they have to perform quarter by quarter so that they can please their investors, their the stockholders, and so for them to keep their head above the water, they have to produce revenue, and on top of that, they have to have their um, they balance their sheet. They have to pay their employees and pay their rents. So these companies have presence around the world, for example, and they've got employees, and of course they've got equipment. The usual business operation expenditure. And so maybe
Mm-hmm.
that's why that you're paying an arm and a leg. They've got high margin, profit margin, and they have to survive. And so that's why maybe people have to pay, especially developers have to pay um, for their usage. But with blockchain solutions, the developers still pay, or the users, but the community operators are paid this time. Maybe not as much because if there's a chunk or like a handful, or let's say thousands, I don't know, I'm not sure what the mechanics are, but this is where probably the proof of stake versus proof of work
Something. Yeah,
mechanism, which we'll probably gonna discuss in a future video. Maybe let's discuss that. Maybe let's find the answers to the questions that we've generated earlier, such as maybe how many nodes are there, or yeah, I think that I need to do my homework on the paragraphs that we discussed so that in the
yeah.
future we can revert back to this.
Okay. So I guess we can proceed uh, to the next paragraphs before, uh, yeah, two more paragraphs. So I'll be reading this next one. In a centralized cloud, decisions are made unilaterally by the controlling corporation. The near community-run cloud is decentralized, so updates must be ultimately be accepted by a sufficient quorum of the network participants. Updates about its future are generated from the community and subject to an inclusive governance process which balances efficiency and security. So I guess uh, how I understand this is if we go back to the centralized cloud examples, Amazon, Google, if they want to decide something on something, maybe an update for all of their terms of service, they are the only ones that can make that decision. Even if maybe the developers that run their applications on decentralized cloud systems, they are at the mercy, I think,
Mm.
of yeah, either Google or Amazon, changing the terms of service whenever they want. So it uh, leaves developers at a disadvantage. But
Yeah.
on the other hand, in like a community run cloud, a decentralized network, that is not the case, right? From what I understand. That uh, I guess it's kind of like a democracy, you can say,
Yeah.
rather than a dictatorship. Is if changes are to be made, it has to be first uh, discussed, and then has to be accepted by maybe a majority of the network participants before it can be implemented. So I guess gives that gives it an advantage because more or less people are uh, changes made are generally accepted by the majority of the network participants.
Yeah. Definitely. There's a process, maybe voting also, um, as opposed to like, yeah, the arbitrary decision of a centralized cloud that is controlled by a few, maybe the board, and also the CEO eventually. So
Yeah, so I guess that's another advantage that decentralized networks have over centralized ones.
mm,
Hey, so I guess we're a little clear on that. So yeah, more details on the governance section of this white paper. I guess we can also discuss that further in another one of our video. But let's go to our last paragraph for this section.
okay, is it my turn now?
Yes.
Okay, it says in order to ensure that the operators of nodes who are anonymous and potentially even malicious run the code with good behavior, they participate in a staking process called proof of stake. In this process, they willingly put a portion of value at risk as a sort of deposit, which they will forfeit if it is proven that they have operated improperly. That's what I was talking about earlier.
Yeah, I guess this is what makes the network secure. Because yeah, in reality, you don't know who these node operators are. They could potentially be malicious. They have ill intent. They may be applied for being node operator.
Yeah.
And so this proof of stake process is like the security that the centralized networks have put in place so that yeah the people you know it's kind of like a you can say a deterrent.
Mm-hmm.
This
Yeah.
proof of stake process is a deterrent for bad guys to do something uh, malicious to the network.
Yep. It is a deterrent.
And so, uh, can you at least give us a better insight on how proof of stake process works?
Mm, I think that this proof of stake is a new breed of um, of a process. Before it was proof of works during in the Bitcoin network. But I think that they say because every block that is being processed becomes more difficult to compute, then 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 it's not sustainable, they say, because proof of work will only be favorable for those who have higher computing powers, those nodes or entities that have professional nodes. But proof of stake, everyone can participate as long as they don't make they don't go rogue. you know,
Yeah.
they don't they don't misbehave. As long as they stay behave, then they will just stay safe. That's why it's called stake. What's at stake here is their reputation
Maybe their
or
assets.
and their assets. So let's say maybe let's put a certain amount of value here or money. Let's say in a form of crypto or maybe form of near as a token. Okay, so you're a node, I'm a node. Okay, I put my stake here, pretty much like a bet, right? Like a pool of money. And
Yeah.
then let's run the whole thing. So as long as everyone is behaving, then I won't lose or like yeah it's not confiscated. So
So this is a portion of their own money, their
mhm.
own. I see. That's why. That's why that acts as a deterrent. It's their own money that they deposit,
Yeah,
their
because
own assets.
yeah, you have skin in the game, so you'd better get your act together. I think it's just a natural psychological behavior that if you're not invested in something, then you don't take it seriously as well. You take it lightly.
Mm.
But if you have a lot at stake, then you'd better get your act together. If not, then the stakes are high, so to
Oh
speak.
yeah, yeah. And so I guess based on what this paragraph is trying to tell us, if they maybe uh, partook of the proof of stake process and they somehow acted maliciously, maybe they, you know, hacked the network or attempted to steal
Hmm.
some money, or some asset, then
Hmm.
this proof of stake of theirs will be forfeited, which means maybe they lose access to that. Essentially, they lose their assets if they uh, have been proven to operate improperly.
Yeah.
I see. Okay. Well, that gives us a better understanding of this process, and how I guess this is a very secure uh, method to be able to run a decentralized network successfully. New learning, new learnings.
Well, it's a process. Yeah.
Yeah. All right. So I guess that we can conclude here for now. We can know more on near protocol, its functions, as we continue with our weekly discussions. I'll stop sharing my screen now.
Yeah. Cool.
Right. So I guess we learned something today, at least how we were able to at least get a general bird's eye view of Near's function, how it works, and basically generally blockchains in general, because I think a lot of blockchains are also functioning that way, most of them.
Yeah.
So before we end, do you have any other thoughts over
I was
you would
thinking that
like to?
not just bird's eye view, but Orvard's eye view on some thought. Mm, yeah, it's educating ourselves is very crucial. And to those who are listening, the devs who are new to blockchain, this could be your springboard, a catalyst for you to get to know more about blockchain from Web 2 to Web 3. I myself am not a developer, but we've got some programs for you sometime in the future. If you want to know more, then reach us out. We're trying to put the links in the description to our landing pages, especially this white paper. Are we going to put this white paper link in the description?
Yeah, we can put this white paper link in the description.
Yeah, and another resources for you to know about near and how you can educate yourself and probably invite others to dabble with the network. Yeah, that's it for me.
Okay, so this ends our weekly discussion for tonight. We hope to see you guys in the next video. At least we could learn more about the Near protocol and blockchains in general. So until next time, see you. Bye.
Bye, guys.